Alright, so we are going to start chapter 8.1. This is going to be our trig function, or our trig chapters. So first thing is, I think, pretty much a review, but I just want to make sure we're all on the same page. So we are going to start off with sine, cosine, and tangent. So first thing, this is a Greek symbol, theta. Okay, so that is how you spell that. And we're going to just make a right triangle just to reference to. Okay, we're going to put theta in this corner. So theta is always going to be an angle measurement. So it's going to be either degree, and eventually you will learn radians. So then this would be a 3 and a 4 and a 5. These numbers obviously can change. The opposite, so this is my opposite of the theta. The adjacent is what is touching it. And then across from the right angle is the hypotenuse. Okay, so then my sine theta is going to be opposite over hypotenuse. And then in my case of the triangle, we are going to have sine theta is going to equal opposite. So that's 4 over hypotenuse, which is 5. So 4/5. Okay. So then my cosine theta is adjacent over hypotenuse. Okay, so then in my triangle, I have cosine, so that's going to, or my adjacent, which is 3, over the hypotenuse, which is 5. So 3/5. Okay, then we're going to work with tangent. Theta is going to equal opposite over adjacent. So opposite is going to be the 4, and the adjacent is going to be the 3. So my tangent theta is going to be 4 over 3. Okay. So then let's just go on to example 1. So on your notes, this is not on there, so draw that picture. Okay, so 15 and 36 are the two legs. I'm pretty sure you guys have heard of the Pythagorean theorem. So what that is, Pythagorean theorem is a squared plus b squared equals c squared. So my a and the b are going to be what's called the legs of a right triangle. So the right triangle is going to be in the middle of those, and then my C is the hypotenuse. Okay, so in this case, I have both of my legs, so my A and my B. It doesn't really matter which one you label A and which one you label B. So I'd have 36 squared plus 15 squared equals C squared. Okay. Doing some of that algebra, you'd have 1,1521 equaling C squared, so 39 is going to equal C. So I'm just going to label this as 39. Okay, so then it does say list sine, cosine, and tangent of theta. So I'm going to have sine theta. If I'm looking at theta, this is going to be my opposite. This is my adjacent. And then this is going to be my hypotenuse. Okay, so sine, once again, is opposite over hypotenuse. So it would be 15 over 39. Okay, you can simplify that. So if you ever can simplify, you need to. So that would be 5 over 13. Okay, you guys may have also have learned, I'll write it back up here, SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay. So then that is my sine. Cosine theta is adjacent, so 36 over hypotenuse, which is 39. This can be simplified to 12 over 13. Okay. M-1 tangent theta is going to be opposite, so 15 over adjacent, which is 36. So then my tangent theta is going to be 5 over 12. Okay. Alright, so then I want you guys to pause the video. I want you guys to try out B. So this is a 16. Your theta is in this one, and then this is 34. Okay, so try this out, and then once you get your answers, play it back and then see if you get the correct answer. Okay, so in order to find this other leg, you are going to have 16 squared plus, we don't know what this side is, so we'll just label it as b squared, equaling c, so 34 squared. Okay. Doing some algebra, you should end up with b squared equaling 900, so then b should equal 30. So we're going to label this as 30. Okay, so opposite from my theta is the 30, adjacent is the 16, and the hypotenuse is that 34. Okay, so sine theta is opposite, so 30 over hypotenuse, which is 34. This can simplify to, I believe, 15 over 17. Okay, and then my cosine theta is adjacent, so 16 over hypotenuse, which is 34. Simplify that one, and you should end up with 8 over 17. And then tangent theta is opposite, so 30 over adjacent, which is 16. And then that does simplify to 15 over 8. Okay. So hopefully, I believe that is all reviewed, but I'm not 100% positive. Next thing we're going to start talking about is our kind of special right triangles. So we do have a 30, 60, 90 and a 45, 45, 90 triangle. So first one we're going to talk about is the 30, 60, 90. So what this is just representing is the angle measurements. Okay, so obviously this is my 90. Doesn't really look like it, but we're going to label this one as 30 or 60 and this one as 30. Okay, so in every one of these triangles, it is going to have the ratio of 1 is my leg across from 30. Okay, the hypotenuse is going to be doubled of that. And the one across from 60 is going to be the square root of 3. Okay, so what this looks like in more of a general form. So here's my 60, 30 triangle again. Okay, so whatever across from the 30 is going to be the short side. Okay, my hypotenuse is always going to be 2 times whatever this side is. So 1 times 2 is 2, so that does work. And then this side over here is going to be my side times the square root of 3, which would be like here, 1 times square root of 3 is the square root of 3. Okay, so this will always be true in a 60, 30, or 30, 60, 90 triangle. With a 45, 45, 90 triangle, so 45, 45, 90, okay, my 2 legs are going to be the same, okay, so if this case, your most like basic kind of one is a 1 and a 1, my hypotenuse is always going to be the square root of 2. In a more general term, I have 45, 45, 90. Okay, so my two sides are the same. And then my hypotenuse is going to be whatever that side is to the square root of 2. Okay, so if you look 1 and 1, my 1's technically in front, so that is where that is coming from. Okay, moving on to page 2. Okay, so write down this triangle. So this is my 90 degrees. So I'm a little off right there. And then 60 degrees and 100 degrees. Or 100, sorry, it's not degrees. Okay, so we are in, obviously then this would be a 30 degrees. So we are in a 30, 60 degree triangle. So the one across from 30 is always going to be S. It's my shortest side. Okay, the one across from 60 is the S root 30. And then the one for my hypotenuse is going to be 2s. Okay, careful, those are s's and not 5s. And if you look here, I do actually have an equation that I could solve. So I have 100 equaling 2s. Well, to get the s by itself, I divide by 2, divide by 2. S is going to equal 50. Okay. So if I'm trying to solve for x, well, this is s root 3, so x would equal 50 root 3. Okay? Okay. If you want to try B, go right ahead. It is a little bit more different. It's up to you though. You can pause it right now and try that one out. Okay. So same idea, this is a 45, 45 degree triangle. We do know my two sides are going to be the s's, so we know s equals x. And then my hypotenuse is going to be s square root 2. Okay, I can solve for this, so I would have 20 equaling s square root 2. Okay, to get the s by itself, I do divide by 2. Divide by 2. Okay. I can't have a square root on bottom, so I do have to rationalize. So I'm going to multiply by the square root to both the numerator and the denominator. So I would have 20 square root 2, and the square root of 2 times the square root of 2 is 2. This can simplify to 10 square root 2, and that is what x would equal. Okay, so we're going to get one more example done today, so example 3. So a builder is constructing a wheelchair ramp from the ground to the deck of a height of 18 inches. So a ramp, we're just going to draw a picture of what a ramp would look like. Okay, so it does say from the ground to the deck is a height of 18 inches. So that is going to be 18. The angle between the ground and the ramp must be 4.8 degrees. So this is the 4.8. To the nearest inch, what should the distance d between the end of the ramp, so end of the ramp, and the deck? So we're looking at that right there. Okay. So 4.8, this is my theta, my angle measurement. We have our opposite, and we also have the adjacent. Okay, so what we're going to look at is what trig function uses opposite and adjacent. So if we go back to SOHCAHTOA, okay, opposite and adjacent is that tangent, so we're going to use tangent. So I want to have tangent of 4.8, so that's the theta, equals opposite, so 18 over d. Okay, So in order to get the d by itself, you're going to cancel those out. So I'd have d times tangent 4.8 equaling 18. Divide by tangent 4.8. Divide by tangent 4.8. Okay. So then that means d would equal, okay, we would type this into our calculators. So I'd have 18 divided by tangent 4.8. Does say round to the nearest inch, so we were looking at this number to round. It's less than 5, so it's going to stay at 214 inches. I want you guys to pause it, and I want you guys to try out example 3B. Alright, so for this one, skateboard ramp. So we're still dealing with a ramp. So I'm just going to draw my triangle. This is my right angle. We'll have a height of 12 inches, so we know this is going to be 12. The angle between the ramp and the ground is 17 degrees. So this is 17 degrees. So right here. Okay. To the nearest inch, what will the length of the ramp be? So this time we're actually looking for this distance. So this is going to be my x value. Okay. So looking at 17, this is my opposite. This is my hypotenuse. Okay. So SOHCAHTOA, we're looking for opposite and hypotenuse. We're going to be using sine. Okay, so I'm going to have sine of 17 is going to equal opposite over hypotenuse. Okay, I'm going to shorthand. I know x is going to equal 12 divided by sine 17. Same idea as what it was up here. Okay, so then x is going to equal, I'm going to do 12 divided by sine 17 is going to give me 41. I'm not going to round up, so 41 inches would be my answer.